Good morning all. In last class we had been discussed about the significance of power electronic converter system in electric vehicle. In today's session we are going to see about the comparison between the electric vehicles and the conventional vehicle. So let us go into the topic now. The comparison of electric vehicle and conventional vehicle comes under the course outcome 1 is to enumerate the layout of electric vehicle, system components and electronic control system, under which the learning outcome 1 is to discuss the layout of an electric vehicle, under which the specific outcome 8 is to compare the electric vehicle and normal vehicle. So in this class, we are going to see about the electric vehicle car with its components and the comparison between electric vehicle as well as the conventional vehicle. This is the diagram of the electric vehicle along with its components. So this area is said to be the traction battery pack. As I told already, the battery pack comprises battery management system and battery modules. And this is the electric traction motor. So the electric vehicle to use the electric motor is the high starting torque motor, which is the electric traction motor. The high starting torque motor available are the permanent magnet brushless DC motor, DC series motor, permanent magnet synchronous motor, switched reluctance motors. So these type of motors are preferably to be used in the electric vehicle. Among them, if it is a low range application of electric vehicle, then permanent magnet brushless DC motor is to be preferred, and if it is a high range application of electric vehicle, in that case permanent magnet synchronous motor or switched reluctance motors are preferred to use in the electric vehicle. Next is the power electronic controller. So based upon the type of motor to be used in the electric vehicle, the power electronic controller can be chosen. The role of the power electronic controller, as we had seen already, it is used to control and condition the electric signal in order to regulate the speed and torque of the electric motor, which is a required purpose for the transmission system of the electric vehicle. Next is a DC to DC converter module, which is used to convert the fixed DC to the variable DC to power up the peripheral devices of the electric vehicles like audio systems, like headlight system of the electric car and all other peripheral devices of the electric vehicle. This is a thermal cooling, so it is used to compensate the heat generation during the operation of the electric car. Next is the battery. We know that it is used to store the energy and to deliver the energy whenever this electric motor is required, the input as electrical resources for its propulsion or its mobilization. Next. So there is a comparison between the electric vehicle and the conventional vehicle. So this is electric vehicle or electric car, and this is a conventional car or a petrol car. So we know that the electric car uses electric motor for its mobilization, and whereas the conventional vehicle or a petrol car, it uses an internal combustion engine for its mobilization or propulsion. Next. So as the electric car uses the electric motor for its mobilization, so and it requires the electrical resources as an input for its mechanical torque and speed generation. It does not pollute the environment at any cost. Whereas in the case of the conventional vehicle, as it uses a IC engine which requires a fuel resource as an input, it always pollute the environment. So this is a main drawback in the case of the conventional vehicle has been concerned. Next. As the electric vehicle uses electric motor, that is AC type induction motor, this motor is developed by the Tesla. So this motor has a weight of approximately about 31.8 kg. For this weight, the power generation of this motor is 270 kilowatt. So if we calculate the weight to the power ratio means we obtain for 1 kg weight of electric motor 8.5 kilowatt of power. Whereas in case of the typical internal combustion engine, its weight is approximately about 180 kilogram and its power generation is 140 kilowatt. So for 1 kg, when we calculate the weight to the power ratio means for 1 kg of the weight, it generates a zero point 0.8 kilowatt of power. So as weight to power ratio has been concerned, this electric vehicle motor has high weight to power ratio as compared with the IC engine as it is used in the conventional vehicles. Next, so the cost comparison. So for 1 mile travel of the electric car, it expenses of $0.03, whereas same 1 mile travel of the conventional car or a petrol car, it expenses of $0.1. So which means that cost is very low in case of the electric vehicle as compared with the conventional vehicle. Next, we see about the some numerical data for the cost comparison between the electric car and the petrol car. So if electric car mileage is of 120 kilometer and the petrol car mileage is of 620 kilometer means then the storage capacity of electric car is 12 unit of electricity and the storage capacity of conventional car or petrol car is 40 liter means then the for 1 unit of electricity, then the energy usage for 1 unit of electricity, the electric car can travel 10 kilometer. Similarly, for 1 liter of petrol, the conventional car or a petrol car can travel 15.5 kilometers. So we know that 1 unit of electricity it expenses of 7.30 rupees, whereas in case of petrol car for 1 liter of petrol it expenses of 82.25 rupees. So for daily expenditure we travel the 50 kilometer in average means in case of electric car it requires the 5 units of electricity. So we know the cost of 1 unit of electricity, then we can calculate the 5 unit of electricity cost, that is 5 into 7.30 which is equal to 36.50 rupees. It is an 1 day cost for average travel of 50 kilometer for a day. Same average travel of 50 kilometer for a day, if it is a petrol car means it requires a 3.225 liter of petrol. So we know that 1 liter of petrol is 82.25. So 3.225 into 82.25, it cost about the 265.256 rupees as a 1 day cost for average travel of the 50 kilometer. So if we take the monthly expense for a month, if we will go for a job for 25 days means in that case we know that 1 day expense of 50 kilometer travel average of both electric car and petrol car. So in electric car 1 day expense of 50 kilometer travel averagely is 36.50 rupees. For 25 days 25 into 36.50 rupees which gives 912.50 rupees. Similarly, we know the 1 day expense of 50 kilometer travel for the petrol car, so which is of 265.256. So for 25 days 25 into 265.256 which gives the cost of 6,631.40 rupees. So which means that cost wise the electric car is more economical as compared to that of the petrol car. That means 5 to 6 times the electric car is economical as compared to the petrol car as the cost parameter has been concerned. So this is what the idea you must know about the electric car and the conventional car, or electric vehicle and the conventional vehicle. Thank you.